Imagine a world where every LED light is an internet access point. Could Li-Fi offer unprecedented bandwidth and data? We are consuming 100% more wireless data every year. That is doubling the amount of wireless data we are consuming from one year to the next. That's exponential growth. But what is exponential growth? Legend has it that chess was invented by an Indian mathematician in the 6th century. The ruler at the time was so impressed with the game that he offered the mathematician any reward he wanted. The mathematician was a humble man, so he asked for 1 grain of rice on the first field of the chessboard, and then doubled on every subsequent field. So 1 grain of rice on the first, 2 on the second, 4 on the third field, and so on. As it happens, a chessboard has 64 fields. The total amount of rice on the 64th chess field is 300 times larger than the global world production of rice for 2016. That's 14 centuries later. That's exponential growth. What we are doing now is that in 2016, we have consumed more wireless data than in the entire history of humanity put together. And some of it might be cat videos, but it's happening nonetheless. So what happens when we move from 5 billion connected devices to 20 billion connected devices? What happens when the Internet of Things becomes a reality? When temperature sensors and pressure sensors and occupancy sensors and CCTV cameras and heart rate monitors are all connected wirelessly everywhere. What happens to all of the information? As everything becomes more digital, what happens to the security of that information? Everything is becoming digital. Our passport numbers, our photos, our fingerprints, our birth certificates, our friends, eating preferences, drinking preferences, good nights out, all of our memories is digital. Everything we know. And every day an institution gets hacked, and every day that information is leaked. In this digital world, we do not have the security of walking in our home and locking the door behind us. So we have an increasing demand for wireless data, we have the increasing vulnerability of that data, and we need energy to fuel all of this. So what happens in a world of 20 billion connected devices? As it turns out, the data centers are just a drop in the ocean for the total energy consumption compared to the wireless access that is required for them. In 2015, according to the Center for Energy Efficient Communications, the world consumed 43 terawatt hours just for accessing the wireless cloud. That's equivalent to the yearly consumption of energy for 2015 of Romania. But there's another piece that also consumes a lot of energy. Light. Light accounts for about 20% of all in-building electricity consumption. Even with LEDs, that's a lot of energy. So we have this unprecedented demand for data, we have the growing vulnerability of that wireless communications, and we have an enormous carbon footprint if we want to keep growing in this exponential fashion. What if data and light use the same power? Could we help solve that problem? Light is very contained. Could we lock the door on our wireless signal? Could we offer unprecedented bandwidth, keep our data safe, and repurpose the energy that we use for illumination to provide wireless communications? Li-Fi can offer all of this and more. Li-Fi was first presented and demonstrated at TED Global in 2011 by Professor Harold Haas. It refers to high-speed, bidirectional, and networked wireless communications using light. It offers users a substantially similar experience as traditional wireless communications, except using the light spectrum. Li-Fi is complementary to traditional wireless communications. Think about how many wireless access points you see right now on your phones. In my flat in Edinburgh, I regularly see 20 to 30 different ones. If I can see them, they can see me. That's interference, that's security. What started off as a relatively big brown box during the 2011 demonstrator has now been reduced to this. This is the world's first Li-Fi dongle by Pure Li-Fi. It's a USB dongle like many other Wi-Fi dongles that you can connect into any USB device and connect wirelessly using Li-Fi to any Li-Fi enabled light. Every communication medium started this way, and over time it has reduced and become a chip which is now in your phones. Li-Fi will be ubiquitous. Li-Fi will be everywhere, and it will just work. So what we have here is a Li-Fi connected tablet with some additional bits and pieces to get the signal back. These lights that are hanging are fully integrated Li-Fi devices, and they are providing wireless connectivity using the light medium. As you can see, they blend with everything else around us, and they're not flickering. So first, we need to try and share the screen, okay? So you can see that. You can see that we are basically in flight mode, and you can see on the screen that the Li-Fi X is there. It's just another wireless access medium. So if we now go to our web browser, if we go to a web page, I can request anything I like. And we can now play a simple video on our website. HD, whatever you like, high speed. The important piece is that this video and this connectivity is available here under this light, and if I move under a different light, my connectivity is handed over and it resumes. This is Li-Fi. It is the ability to transmit data wirelessly and be handed over from one light source to another. It is this ability to move freely around a location which allows us to connect wirelessly and to provide the user with the same experience as traditional wireless communications, except using the light medium. So, this brings us to a very important point. You can see that both of these lights are approximately 3 meters apart from each other. All of the light spectrum, all of that wireless data is being provided by this light and is not interfered with this light. That's a fundamental principle of increasing the density of wireless access points. It means I can use all of the spectrum in one location and reuse all of the spectrum just a couple of meters further. This is how Li-Fi solves the exponential growth in the demand for mobile data. This is how we move from traditional wireless communications to light. It is this ability to provide a greater spectral reuse and spatial reuse that will allow us to continue this growth. So, you may have seen, can we go to the next slide? Yep. As you saw, Li-Fi provides both uplink and downlink. It means I can upload a video, have a Skype video call, and download information seamlessly. It means I can provide high-speed data rate, not just one-directional, low data rate, as some systems out there. The lights are not flickering. They're not interfering with anyone. In fact, the rate of change of the LED light is so fast that we needed a special receiver to detect that. And they can work when the lights are dimmed. So if you're at home and you're watching a movie and you dim the lights, or if you're in a restaurant that has a dimmed ambiance, Li-Fi will still work. It works in daylight. Now, this isn't really a problem for the UK, but in some places where there's a lot of sunlight, it matters. And what this means is you can have smart cities. Light posts connected to light posts, cars connected to cars, all of it with Li-Fi without problems. And so, next slide, please. Li-Fi is a reality today. It is ready for the enterprise market. It is being installed in the headquarters of Nexity and Sogeprom, both some of France's largest property developers. It is installed in the headquarters of Microsoft in Paris, in the University of Edinburgh, in the University of Strathclyde, and many other locations. Li-Fi is a reality today for the enterprise market, and it will be in the future for the consumer. It will transform the lighting industry in the same manner that mobile internet transformed mobile phones, providing a unique combination that will offer incredible advantages. With Li-Fi, a world connected by light has become a reality. Light will always be here. Li-Fi will offer the world unprecedented bandwidth and data to continue our exponential growth. Thank you.